Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good morning. Today we will continue our lecture with chapter 5, system protection. But before that, we recite first surah Al-Fatihah. Alhamdulillah. Ya, surah Al-Ladzina. Okay, so today we continue with chapter 5, the system protection. Okay, so this is the outlines of this chapter. We have introduction to building protection system, and then earthing system, protection against electric shocks, earth fault protection, and finally the protection against voltage surge. So first is we have to know what is earthing. Okay, so the meaning of earth is the conductive mass of the earth whose electric potential at any point is conventionally taken as zero. Okay, so an earth is defined as a connection to the general mass of the earth. So this is an example of a block of flats. Okay, so from here you can see number one is the earth electrode. This one, okay, this one is the earth electrode. And then number two is so this one is the earth electrode. Okay, so you refer to this point and then you refer to the numbering at the diagram. So this one, number one, is the earth electrode. Number two is earthing conductor. So this one is the earthing conductor. Number three, okay, this one, three is the protective conductor. And then four is the electrical installation. This one. And then five is the bonding conductor. Six is the main earthing terminal. And seven is the removal link. Okay, we look one by one, okay? First, what is the earth electrode? Earth electrode is a conducting element which buried directly in the ground. So we have to bury this earth electrode directly in the ground, facilitating the flow of fault currents towards the ground. Okay, that is earth electrode. Okay, number two is the earthing conductor. So earthing conductor is commonly called the earthing lead. It joins the installation earthing terminal, this one, okay, earthing terminal, and then to the earth electrode. So it joins between the earth terminal and earth electrode that we call the earthing conductors, okay. And then number three is the protective conductor, this one, okay. So protective conductors connect the conductive parts of casings in electrical appliances, conductive parts of building and constructions to the earthing electrodes. Okay, so it connects all this equipment to the earthing electrode. Okay, number four is the electrical installation. Okay, so this one, electrical installation. So electrical installation is an electrical wiring of cabling and associated devices such as switches, distribution board in a structure. Okay, and then number four is the bonding conductor. This one, sorry, number five. Number five is we have the bonding conductor. Okay, the bonding conductor. So bonding conductor is bonding to electrical earth is used extensively to ensure all conductors, for example, person, surface and product, are at the same electrical potential. Okay, when all conductors are at the same potential, so no discharge can occur. Okay, so basically we just to this bonding, the purpose of this bonding is to make sure that we'll have the same electrical potential between the person, surface and product with the earth. Okay, and then number 6 is the main earthing terminal. So this one, main number 6, which one? Okay, this one. So main earthing terminal is a terminal or bus bar which is part of the earthing management of an installation and which enables the electric connection of a number of conductors for earthing purposes. So it connects all together for the earthing purposes. And then number 7, 7 is removable link. It's allow an earth electrode resistant check. Okay, so we go further. What is earthing? Okay, so earthing, physically earthing is a conductor or other metal is earth when it is effectively connected to the general mass of earth by means of a metal rod or a system of metal water pipes or other conducting object. So solidly earthed or bolted earth when it is earthed without the intervention of a fuse, switch, circuit breaker, resistor, reactor or solenoid. So means that, for example, the body of the equipment or non-current carrying part, we connect it to the earth, so it also called the earthing. Yeah? So for example, we have here is the induction motor and induction motor. Okay, then you connect here cable, conductor, earthing. So this is also called earthing. Okay, so this is what we call earthing. So earthing is meant by having every item of apparatus and every conductor be prevented from giving rise to earth leakage currents. It is carried out by ensuring any metal liable to become charged should be earth and every part of the earthing circuit should be properly installed. Okay. So other alternatives to earthing that could be employed are by having an all-insulated construction, double insulation, and by having any an isolation. Okay, that is alternative to earthing. So earthing purposely to protect people and equipment from potentially dangerous overvoltage and leakage associated with electrical equipment in homes, offices, retail outlets and industrial plant. So it's very important to do the earthing system. Okay, for example, if there is a fault in your electrical installation, you could get an electric shock if you touch a live metal part. So this is because the electricity may use your body as a path from the live part to the earth part. So earthing is used to protect you from an electric shock. Okay, so for instance, at your house, you have a rice cooker, right? So if a rice cooker has a fault, the fault current flows to earth through the protective earthing conductors. Okay, and then a protective devices such as fuse or circuit breaker in the consumer unit switches off the electrical supply to the cooker. Then the cooker is now safe from causing an electric shock to anyone who touches it. So that is the important things why we need an earthing system in our, especially in our house. Okay. And then we also has to differentiate between grounding versus bonding. Okay, grounding is connecting the equipment and points on electrical system to the earth or an earth substitute. Okay, for instance, if we look at the generator or the alternator, so the neutral point of this generator or alternator, we connect it to the earth. So this called grounding. So for example, we have uh, star connection here. Okay, okay, we have here. Okay, and then we have here. Okay, and then we have the neutral parts here. Then we ground. So this one R, Y, B, for example, and then this one is the neutral. So when the neutral points, we connect it to the earth. Okay, this one is earth. Okay, so this we call as the grounding. So that you have to differentiate between the grounding, the earthing, and also the bonding. Okay. So purpose of this grounding is to limit overvoltage between the equipment and the earth due to the lightning, faults, etc. Okay. And then bonding. Bonding, if you see, refer to here is number 5. Bonding conductor. So bonding is connecting equipment together and to the same system neutral point. So purpose is to limit voltages between equipment and to provide a path for ground fault current. That one we call bonding. Okay. We connect equipment together and to the same system neutral point. Okay. So this is the diagram of the grounding versus bonding. We can see the differences here. So if you look at here, we have the hot wires, we have the neutral wires. So hot wires will carry the electricity, the current from the supply. Okay, this one is the supply to the loads. Okay, so the hot wires will carry the electricity from supply to the load, while neutral wire, so this one is the neutral wire, this one is the neutral wire, carries the electricity back to the supply. Okay, so we can see here, here is the, we call grounding. Okay, this one is grounding, and then here is, we call bonding. Okay, when we connect with two equipment, okay, for example here service panel and also the end user equipment, we connect it together, then we call it as a ground, as a bonding. So this bonding is purposely to make the potential is same. Okay, so it will avoid us with the electric shock event. Okay, now we look at the reasons for earthing. Okay, the first one reasons is to minimize the over voltage. Okay, so lightning, line surge, or unintentional contact with higher voltage lines can cause dangerously high voltage to the electrical distribution system. So this earthing, provides an alternative path around the electrical system to minimize the damage in the system. Okay. Okay. The second reason why we need the earthing is to limit voltage potential on equipment enclosures. Okay. So this, the first diagram is the ungrounded motor frame. So there is no grounded for this motor frame. The second diagram, we have the equipment of earthing conductor. So grounding or earthing metal electrical enclosures such as these motor frames puts both the earth and the metal enclosure at the same potential, which is the voltage, which is zero potential, same as the earth. Okay, so with both the metal enclosures and earth at the same potential, shock hazards are reduced and an electrically conductive path for any fault current to flows is establishes. Okay, so the third reason is to provide a low impedance path for fault current. So the equipment earthing conductors puts all metal enclosures at earth potential, which is V, okay, equivalent to 0, along the way, and also provides a low impedance path for fault current to flow on it if a ground fault should occur in the system. So there's an alternative path that the current can flow to the earth in order to protect the devices. Okay, so reasons for earthing. Why we need this earthing system? So designing a safe earthing system means providing the easiest and shortest path for the fault current without exposing a person to electric shock. Okay, more on the protection for the human being. Satisfactory earthing is the most important part of an electrical installation because operation of all the protective devices depends upon the earthing system. Okay. And then we have the earth continuity path. The total impedance Z of the conductor connecting the metalwork of the installation to the earth electrode, earth continuity conductor measured between the earth electrode and any other part of the installation at supply frequency should not exceed 1 ohm. So if the resistance is higher than 1 ohm, it means that these have the excessive resistance, and this indicates that improper earthing. Okay, so we also have to do the earth continuity test, where the purpose of this test is to check that there is a good connection between the earth pin on the plug and the case of the appliances. A good connection is defined as having a resistance of less than 0.1 ohm. Okay, what causes of this excessive resistance? There are 5 causes. The first one is the earth lug terminal rusty, the loose wire connection, layers of paint on the electric apparatus, loose connection of earth wire to the plug and socket outlet, and loose connection between conduit and terminal box. Okay, so if a circuit has excessive resistance, it will prevent the wire or component from carrying sufficient current under high load conditions. Okay, so we have to avoid the excessive resistance. Next is the codings in earthing arrangement. Okay, so IEC standard 60364 specifies a 2-letter codes to identify type of earthing. It also defines 3 families of earthing arrangements. Okay, the 2-letter code is based on source sites and also the device side earthing. The first letter indicates how the earthing is done on the source side, which is normally generator and transformer, while the second letter indicates how the earthing is done on the device side, which is placed where electricity is consumed at the consumer premises. Okay, so the letter used are as follows. The first one is T, or terre, French word for earth. Okay, it means direct connection of a point to earth. And then I is isolation, all live parts isolated from earth or supply connected to earth through an impedance for isolation. And then we have N. N is the neutral. In AC system, the earth point is normally the neutral point. And the S, separate, which is the neutral and protective functions, which is the protective earth provided by separate conductors. And then we have C, which is the combined neutral and protective functions combined in a single conductor, or we call PEN, PEN, protective earth and neutral. Okay, now we continue with the types of earthing arrangement. So normally there are 3 types of earthing arrangement, which is TT, TN and IT. So we will look further for each of this type. Okay, The first one is the TT system, earth neutral. Okay, so from here you can see this is all the conductor lines, L1, L2, L3. This one is the transformer. Okay, this one is the transformer, and then this one all the conductors, and then we have here is the neutral conductor, also called this is a neutral, and it is the conductor that connects the star point in a three-phase system to the earth. Okay, and then we have the second one is this one, PE. So PE is the protective earth, is the conductor that connects the exposed metallic parts of the consumer's electric installation to the ground. Okay, so this TT system, one point at the supply source is connected directly to the earth. Okay, so this one is connected directly to the earth. All exposed and extraneous conductive parts are connected to a separate earth electrode at the installation for the load parts. So this electrode may or may not be electrically independent of the source electrode. So in TT system, consumer employs its own local earth connection in the premises, which is independent of any earth connection at source side. Okay, this type of earthing is preferred in telecommunication applications because this system is free of any high or low frequency noise that comes through neutral wire connected to the equipment. Okay, that one is the TT system. The second one is the TN system. Okay, TN system, we have three types of TN, which is TNC, TNS, and TNCS. Okay, so we look on the TNC first. Okay, so TNC, the neutral conductor is also known as a protective conductor and is referred to as a PEN, protective earth and neutral conductor, this one. Okay, so basically for these types of earthing arrangement is C is referring to the combination of the neutral and the protective earth conductors. So it is a PEN conductor. It combines the neutral and also the protective earth. Okay. And then we have TNS. TNS, S is stand for separate. The neutral and also the protective earth is separate. Okay, here. So you can see here P, E, and also N is separate. So the protective conductor and the neutral conductor are separate. On underground cable system, when lead shaft cables exist, the protective conductor is generally the lead sheath. Okay, so in this system, separate conductors for the protective earth, PE, and also neutral, run from the consumer electrical installation till the source. They are connected together only at the power source. So the earth is connected at the power source only. That is TNS. And then we have the TNCS system, which is combined and separate system. So in the TNCS system, the TNC4 wires system must never be used downstream of the TNS 5-wire system, since any accidental interruption in the neutral on the upstream part would lead to an interruption in the protective conductor in the downstream part and therefore a danger. So you can see here, this is the TNC, right? Okay, it's combined. They use the PEN conductor. Then this one we have the TNS. Okay, TNS, because it separate the PE and also N, and also this one also TNS, while this one is TNC and this one is TNC. Okay, so TNC means that it combines, they use the neutral and also the PEN. So in this system, these two systems is TNC system, and it is not permitted downstream for this TNS after the TNS scheme. Okay, because of it connects to the neutral. So if any accidental interruption in the neutral, it will interrupt all the system. Okay. Okay, and then we have IT. The third one is IT. IT system, it means that isolated neutral. We isolate the neutral. Neutral, so you can see here isolated or impedant earth. We have two types. The first is the isolated neutral, or the second part, this one, is the impedant earth neutral. Okay, so for this isolated neutral, no intentional connection is made between the neutral point of the supply source and earth. Okay, and then exposed and extraneous conductive parts of the installation are connected to an earth electrode. The second one is the impedance earth neutral. So an impedance ZS in the order of 1 to 2 kilo ohms is connected permanently between the neutral point of the transformer low voltage winding and earth. So we connect with the ZS here. So in practice, all circuits have leakage impedances to earth. For example, in a low voltage phase 3 wire system, 1 kilometer of cable, we have a leakage impedance which is equivalent to 3 to 4 kilo ohms. So this impedance ZS of 1 to 2 kilo ohms, we connected permanently between the neutral point of the transformer for the low voltage winding and the earth. So the reason of connecting this impedance to neutral is to fix the potential of a small network respect to earth and to reduce the level of overvoltage such as transmitted surges from the MV windings, static charges, and etc. with respect of the earth. Okay. So this is the characteristic of TT system. Okay, we look at more onto the application of this TT system. Okay, so TT means that the supply, okay, this one, the supply, and also the supply which is the transformer part, the neutral is connected to the earth. And then this one is the load. Load also connect to the earth. Okay. So this is a simpler solution to design and install. Used in installations supplied directly by the public low voltage distribution network. It does not require continuous monitoring during operation. And then protection is ensured by special devices, which is the residual current devices, RCD, which also prevent the risk of fire when they are set to 500 milliamps. Each insulation fault results in an interruption in the supply of power. However, the outage is limited to the faulty circuit by installing the RCDs in series or parallel. Loads or parts of the installation which during normal operation cause high leakage currents require special measures to avoid nuisance tripping. Okay, so basically TT is mainly for consumer power supplies. For instance, the network with outdoor overhead, supply via star connected power transformer, private substation, and then building protection lines and building protection, and also installation where the continuity of a circuit is uncertain, for example, work sites or old installation. Okay, what is the application of the TT system? Okay, this is the explanation. Okay, and then we have the second one is the TN system. The first one is the TNC system. The second one is the TNS system. C stand for combined, which is use PEN. S is separate, the neutral and also the protective earth is separate. Okay. So this TNS, the consumer's earthing terminal is usually connected to the metallic part of the distributor cable. This is used for underground power supply to the premise or factory from distributor substation. Okay, TNC normally we use for the consumer earthing terminal, such as place that has potential leakage current, for example bathrooms. Okay, and then high power gadgets, for example at the kitchen, light power loads, for example at bedrooms, and also machine tools. Okay, while for this TNS normally we use for the machine tools, for example electronic equipment such as computers and PLC. Okay, so the characteristic of this TN system, they requires the installation of earth electrodes at regular intervals throughout the installation, requires that the initial check on effective tripping for the first installation fault to be carried out by calculations during the design stage, followed by mandatory measurements to confirm tripping during commissioning. Requires that any modification or extension be designed and carried out by a qualified electrician, may result in the case of installation faults in greater damage to the windings of rotating machines, and may on premises with a risk of fire represent a greater danger to the higher fault currents. Okay, and then the characteristic of the IT system. So we have the connecting. This one is connecting the impedance earth neutral. Okay, the impedance earth neutral. So solution of offering the best continuity of service during operation. Indication of the first installation fault followed by mandatory location and clearing ensures systematic prevention of supply outage. Generally used in installations supplied by a private medium voltage or low voltage low voltage transformer, requires maintenance personnel for monitoring and operation, and requires a high level of insulation in the network, implies breaking up the network if it's very large, and the use of circuit separation transformers to supply loads with high leakage currents. So IT system is similar with TT system, but the difference is in earthing supply. So the distributor system has only a high impedance connection. So example of this application for IT system such as emergency standby generator, load sensitive to high fault currents such as motors, and then premises with risk of fire, machine control monitoring network, and etc. Okay. So I would like to suggest for all of you lah to investigate the suitable earthing arrangement for electrical appliances. Okay, next is the electric shock event. An electric shock is the pathophysiological effect of an electric current through the human body. So the degree of danger for the victim is a function of the magnitude of the current, the parts of the body through which the current passes, because our body is a conductor, and the duration of current flow, the time taken. Okay, so when the current greater than 30 milliamps, okay, only 30 milliamps passes through a human being from one hand to feet. The person concerned is likely to be killed unless the current is interrupted in a relatively short time. Okay, so only 30 milliamps can kill human beings. So you have to be careful with the electric current. Okay. So for the electric shock, there are two events, which is the direct contact and indirect contact. For the direct contact, it refers to a person coming into contact with a conductor which is live in normal circumstances. So it direct touch the live cable, for example. So it is a direct contact. So indirect contact refers to a person coming into contact with an exposed conductive part, which is not, okay, with exposed conductive part, okay, this one, exposed conductive part, which is not normally live, okay, but has become alive accidentally due to insulation failure or some other cause, okay. So this is the figure, shows how the electric shock happens. Okay, current flow from the transformer, from the supply, okay, to the distribution board of the consumer unit. Then this current wave flows to the machine operated by the man. Okay, so if the fault occurs at the machine and have leakage current plus the RCD is not functioning well, then the current will flow to the human body. Okay, so as our body is conductor, plus this man, he holds the metal gas pipe where also is a conductor. So the current will pass through the pipe and go through the ground and back to the supply. Okay, so this man will be facing an electric shock that can kill him if the protection is not available or not functioning well. So we have to protect against this direct and indirect contact. So how we want to protect is we have to protect the insulation life of part. Okay, so we insulate the cable. And then protection by means of barriers or enclosures. So we use the envelope to cover the live conductor. And then we use the residual current devices, okay, or RCD, operating device, which operate at 30 milliamp or less and are referred to as RCDs of high sensitivity. As I mentioned before, the RCD has many types of sensitivity. So we have 100 milliamps, 30 milliamps, and 10 milliamps. So normally we use the 100 milliamps for lighting circuit, 30 milliamps for power circuit, and 10 milliamps, for example, the high sensitivity circuit, for example, water heater. Okay, so protection against indirect contact, the earthing of all exposed conductive parts of electrical equipment in the installation, and this one is the construction. Okay, and the construction of an equipotential bonding network. So we have two earth of these conductive parts. Okay, and then we also can use the automatic disconnection of the supply of the section of the installation concerned in such a way that the touch voltage or the time safety requirements are respected for any level of touch voltage VC. Okay, so this one, this diagram, VC is here. So touch voltage is the voltage between the energized object and the feet of the person in contact with the object. So the maximum safe duration, okay, which is the disconnecting time of the assumed values of AC touch voltage in seconds, not exceeding 32 amps as shown in this table. Okay, so we have here, this one is the voltage, touch voltage, and then we have the earthing system, either TN or IT or TT, and this one is the disconnecting time in seconds. Okay, so for instance, we see at the arrangement, the earthing arrangement for TN or IT, okay, system for touch voltage range between 50 to 120 volts. So the disconnecting time is 0.8 seconds. Okay, so this is the automatic disconnection for the TT system. Okay, so this one, in the event of an insulation fault in the receiver, okay, this one we have the insulation here. The fault current IF flows, okay, flows in the circuit called the fault loop. The impedance of the earth fault loop consists mainly in the two earth electrodes. For example, here is the source and the installation electrodes in series. Okay, so the loop is closed by the transformer winding. So the current will flow here and go back to the transformer windings and the power supply circuit. So logically, therefore, the impedance of this loop should be calculated for all the elements in series which make up this loop. Okay, this is a closed loop system. So the magnitude of the earth fault current is generally too small to operate the overcurrent relay or fuses, and the use of a residual current operated device, which is the RCD, is essential. So in this system, small current milliamps are detected. Okay, that's why we can use only the RCD instead of OCR or fuses. So protection by automatic disconnection of the supply used in TT system is by RCD of sensitivity by this equation. Okay, so I theta n, which is the sensitivity threshold of the residual current device, is equal or less than 50 over RE, and RE is the resistance of the earth electrode for the installation. Okay, this one is the automatic disconnection for TN system. Okay, so in this figure, the method TNC combined is shown, which the neutral conductor act as both the protective earth and neutral PAN conductor. Okay, so in all these TN systems, any insulation fault to earth results in a phase to neutral short circuit. High fault current levels allow to use the overcurrent relay protection, but can give rise to touch voltages exceeding 50% of the phase to neutral voltage at the fault position during the short disconnection time. So this system, we can use the circuit breaker, fuses, and RCDs may be necessary on the T and earth systems. Okay. So this is the automatic disconnection for IT systems. Okay, so there are two types of fault situation in IT system, which is the first fault and the second fault event. Okay, and this diagram shows the first fault situation. Okay, this one only one fault happens. So it is the first fault situation. So on the occurrence of a true fault to earth, referred to as a first fault, the fault current is very low and no dangerous fault voltages can occur. So in IT system, the first fault to earth should not cause any disconnection, okay, because of the fault current is very low. However, in this system, we have to consider a permanent monitoring of the insulation to earth must be provided, coupled with an alarm signal, which is audio and or flashing lights, etc., operating in the event of the first earth fault. Okay, so during a phase to earth fault, the current passing through the electrode resistant RNA here, okay, is the vector sum of the capacitive currents in the two healthy phases. So here, as we can see, we have ID. Okay, this one is ID1. And then here we have ID2. So the current passing through this RNA resistance is ID equivalent to ID1 plus ID2. Okay, so from here, go here, and then go there, and go there. So that one is the current. So on the appearance of the second fault, for example, here, if there is the second fault happen here, on a different phase or on a neutral conductor, a rapid disconnection becomes imperative because the simultaneous existence of two earth faults, which if both not same phase is very dangerous. Okay, so hence this second fault, we need the use of the circuit breaker, fuses, and RCDs in this system, which is ITL system for second fault. Okay, and this is the explanation on the automatic disconnection for IT system.